All right, we'll go ahead and get started. This is domain name security extensions, in case you want it to be somewhere else. Okay. All right, so quick question. How many of you have trusted the DNS today? Did you feel good about trusting the DNS today? Yeah, kind of. Okay, well, that's good. That's good. All right, these are some stats that I'm not going to read to you, but essentially, the internet as we know it, while we as engineers know that the machines only care about IP addresses, right? The internet as we know it would not function as it does if humans could not use names that we recognize, right? Okay. So was anyone doing DNS things back in 2008 when the Kaminsky attack was revealed? Yeah, okay. That's good. I have a lot to tell you about then. So back in 2008, there was, I'm sure you've heard of the Kaminsky style attack, okay? And this was a vulnerability in the protocol itself. I'll talk about it a little bit more later, but essentially within about 10 seconds, I could guarantee that I could take over the DNS for your domain, okay? And this was really pretty easy to do. So the way I always think of it is like, imagine if the internet's DNS was determined by essentially 15-year-old males. This would not be a good thing, right? Okay. All right. First, a little bit about myself. I am Eddy Winstead. I work for Internet Systems Consortium. We are a nonprofit. You probably know us best as the authors and maintainers of Bind. We also do the same for ISC DHCP. And we do operate FRoot, one of the 13 root name servers. Okay. Again, we are a nonprofit, and 90% of everything I'm going to present today is based on DNS protocol. It is not Bind specific. I will have some reference slides about how you implement DNSSEC in Bind, but know that you can do this with any other name server software as well. So they all support it. Our friends over at NONet Labs with Unbound, CZNIC with Not DNS, Nominum, Microsoft DNS, all these things you're able to do what I'm going to talk about today, okay? That said, if you have specific questions about implementation, I guarantee you I can answer your question with Bind, maybe not with the others. We'll see though, okay? All right, if you take nothing else from this talk, here's the thing you need to get, okay? The DNS protocol is over 30 years old, right? It's exactly like 33 years old. This is pretty amazing what it's been able to do, right? Okay. The thing you want to know from this talk is you have DNS data, you have this already. So you have, for example, www.yourcompany.com has an A record of this data, right? You have that. It's already in existence, it's no problem. What we're doing with DNSSEC very simply is we're adding a signature to augment that data. That's it. All right, so if you take nothing else away from this, that's what you need to know. All right, so I have an A record. With DNSSEC, I'm going to add what's called a resource record signature. I'm just adding a signature to that record, right? Now, how you create that signature, what other name servers do with that signature, that's all the meaty parts of how DNSSEC works. But you as an operator, this is you're just adding additional data for someone else to query and use for validation, okay? Right, so types of name servers. You have authoritative name servers that provide data. So I am, for example, my name servers are authoritative for isc.org. I put data in those name servers and they serve that out to other name servers that query my server, okay? These other name servers that query my authoritative server are what we refer to as recursive name servers, all right? Recursive name servers historically do these questions on behalf of clients. So for example, on the NANOG network here, you know, there's 862 of us, so what's that, probably 1,000 clients, devices. We're all asking questions of some DNS servers that NANOG has set up. And every question that we ask, it goes out and talks to the authoritative servers to get the answers. Okay? Good. Here's some tricky parts about DNSSEC. This talk is going to be a lot of good news, bad news, right? DNSSEC makes it so you cannot cache poison the DNS, right? This is good. This is what we want. It does make your DNS infrastructure more brittle, okay? So good news, bad news on that. So if, for example, I deploy DNSSEC on the validating side, so typically if you're like an ISP, you're answering questions on behalf of your customers, you deploy DNSSEC validation. If ISC.org messes up my DNSSEC deployment on the authoritative side, you're the one, even though I made the mistake, it's going to be you who starts answering the phone about the problem. Okay, this is one of the operational nightmares about DNSSEC. Okay, I messed things up, you get the phone call. This is not what any of us want, right? Because then you're in a situation of trying to explain to your customer why you do DNSSEC, why it's important, when all your customer really wants is to get to the website. That's usually what they care about, right? Right, so the point here is that if you, so how many DNS geeks do I have? Any DNS geeks? Kinda? Okay, cool. Anybody, this is how I always tell. Who in here is not asking DNS questions of the NANOG name servers, but you're asking your own questions from your laptop? Oh, maybe some, okay. This is good. Okay, we'll get to this a little later, okay. Well, in DNS headers, there are flags, right? And one of the most common is if I ask, if I'm a recursive server and I ask an authoritative server, you know, what is www.isc.org, then that authoritative server will respond to me and say www.isc.org's address is this, and in the headers of that response will be a flag that's set as AA. This is authoritative answer, okay? When we start talking about DNSSEC, the flag that you're looking for, the money bit, so to speak, is AD. You want to see authenticated data, okay? And we'll talk about how you get that. The problem is if I'm deploying DNSSEC validation, and you have, again, back to that example, if I've messed up my DNSSEC deployment, and you cannot validate me, and I was talking to someone in the earlier session, and maybe this is what they were sort of experiencing, but if you cannot validate me, then your clients are going to get, in response to their queries for isc.org, they're going to get serve fail. Serve fail is bad in DNS world, right? That's what you don't want. Okay, so again, DNSSEC is great. It solves the cache poisoning problem, but it does make things a little more brittle for you as operators to deal with. All right? Okay. So before we get into the actual DNSSEC parts, we'll talk a little bit about how the DNS is structured so we can help understand why things are structured this way for DNSSEC, okay? All right, so I've already talked about the sum, but in general, a client is asking a question, a recursive server is re-asking that question on behalf of a client, and then authoritative servers are providing those answers, okay? Those answers are then cached by almost always the recursive server, sometimes by the clients as well. Okay. Okay. So in general, we're doing queries. These originate within applications. The one that we're most familiar with is the web browser, but of course, all of us know, those of us that live at the command line, we can do things that induce DNS lookups, right? Now, on the client itself, just right quick, this is usually handled by what's called the stub resolver. If you're of the Nix persuasion, then this is in etcresolve.conf. You have some name server entries in there, and they point to some IP addresses that answer DNS queries on your behalf. Okay. All right. So let's look at this in pretty pictures. So here I have my client at the bottom, the laptop. This client wants to go to www.example.com. He asks his local caching DNS server, what is the address for www.example.com. If this server has just started up, then it's not going to have anything in its cache. All right, it's going to have what we call root hints. Root hints is the 13 root name servers and their addresses. Okay. So, yep, that's what I just said. So I'm going to go out and at this point in how the DNS protocol is written, there's some effort underfoot to change this, but as things are written now, I'm going to ask for www.example.com of the root servers. The root servers are going to then reply to me and say, I don't know the answer to your question, but I have some information that will be useful to you. This is called a referral in the DNS protocol. So it sends back a list of these 13 root name servers. I'm sorry, it sends back the list of the top-level domain servers. So then I'm going to go ask a top-level domain server the same question, and this process repeats. I don't know the answer to your specific question, but I do know where you can get the answer. Here are the name servers for example.com. So now that I have this information, I can specifically ask the name servers example.com this question, and I can get back an answer, and my client is happy, okay? At this juncture, though, I'm going to talk about a few things, right? This is incredibly simplistic, all right? I've got one client asking one resolver. Usually you have at least 2 resolvers in the mix, sometimes many, many more. If you're a very large ISP, you can have, I don't know, 50, 100. You can have lots of resolvers for your clients. And then on the authoritative side, I'm showing one root server. There's actually 13 root instances, but most of them are anycasted these days. So you've got a lot of devices there. Same thing with the TLD servers. And for example.com, you're going to have a minimum of 2. You may have, however many you want to have, okay? So this is a very pretty picture of DNS, but in reality, DNS is not pretty like that. It's really kind of crazy, all right? There's queries going everywhere. And this is all based on if we're all following the protocol, all right? Lots of clients aren't, protocol compliant, right? Things still work, right? This is also the beauty of the DNS, right? It still works. It's kind of amazing. Anyway, you probably don't want to hear that from me. All right, so again, I said this is, the protocol itself is 33 years old. Kudos to the designers of the original protocol. Dr. Paul Makapetris is one of those, the primary one. And in terms of what it was designed for, it has done exceptionally well, right? It was designed so that we could do delegation, that if I am ISC.org, I want to control my namespace, all right? I want to be able to add, modify, remove things within ISC.org without talking to another party, right? It accomplished that. Scalability. Did any of us think 33 years ago that the internet was going to be what it is today? No, right? So it has scaled exceptionally well. Security, though, it was not designed for, okay? I had a sort of a hallway conversation with Paul Makapetris once, and the statement sort of stood out for me, and it is that he says when people come to him and say, hey, I've discovered a new security flaw in your DNS protocol, he says to them, that's impossible. It wasn't designed for security, right? And it wasn't. That's why we're talking about DNSSEC. The other thing about DNSSEC that I want to stress to you is that this is about proving that the data, the DNS responses came from who they're supposed to come from and that it hasn't changed. This is not about securing your name servers, right? That's a whole different topic, right? Making sure your OS is secured and hardened and all that kind of stuff on your name servers is not part of what we talk about with DNSSEC. This is only about the data, okay? All right, so this cache poisoning thing. All right. I'm going to step back just a sec on this. So to note how we accomplished, I said delegation was very important in the original DNS protocol design. How that was accomplished is via what we call an NS record. All right. Who in here is familiar with an NS record in DNS? All right, excellent. So NS is for name server, right? So remember I said if I ask the root server for www.example.com, it sends me back a referral. And in that referral, it contains NS records for, in this case, the TLD.com and the addresses of those name servers, right? So this is how we accomplish delegation. This is called the chain of authority. And there are a couple of terms that I'll say over and over until you get tired of them, I promise. Chain of authority is one of them. We accomplish this with NS records. When we talk about DNSSEC, it's going to be called, we have an additional record now called a DS record. And this is a delegation signer. So the NS record is creating my delegation. My DS record is signing that delegation. All right? Okay, a little bit more about to the problem that we're trying to solve here. So, excuse me. What if I could do things to your resolver, okay? So you're an ISP, you have these resolvers, you have clients that are asking you questions. What if I could insert data into your resolver that was incorrect, right? So I could do all kinds of nasty things if I was able to do that, right? Unfortunately, because DNS was not designed for security, we have a history of these things occurring. There's been quite a few sort of famous ones. Eugene Kasparev poisoned Internic.net way back in the early 90s. The Kaminsky attack, and there's been a few others, right? So there's been these moments in internet history where people have said, oh no, the DNS is insecure, right? Because someone was able to poison someone's cache, right? Well, those of us that know the DNS protocol, we're always like, well, yeah, it wasn't designed for security, all right? There's this thing called DNSSEC. That's how you solve this problem, right? Well, the thing of it is, though, is that each time there's been an event, there have been what I call band-aids, right? So we have these, we have the protocol implementations and name server software. People determine problems, and then we put on these sort of band-aids to fix the problem so that people don't have to deploy DNSSEC fully. Okay, this has just sort of been the way things have worked out, all right? And I'll show you a couple of these examples as well. All right. Yeah, so this is one of the early ones. This is how the Internic cache poisoning thing happened. Is anyone familiar with the additional section in a DNS response? Yep, okay, good. So I've used a very simplistic example so far. I ask you about www.example.com. You, as an authoritative server, send me back a response that contains the answer to my question. Well, there's also, as part of the protocol, an additional section in that response. And in that additional section, the authoritative server can send back what it pleases. All right. So, in terms of what an untampered with authoritative server sends back, it's all legit. It's just sending back information that you might be interested in, such as things like NS records for the zone you ask about, or glue records, et cetera, et cetera. Now, if someone wants to do something malicious, they could send something else back in that additional section. Okay. So here, these are the 5 sections of any DNS message. That's queries, responses, updates. They all have this. They have header, question, answer, authority, and additional. Okay. So here I'm asking for www.isc.org. I get back an address. And by the way, additionally, you might want to know that www.bank.com lives at this address. All right. So this brings up the most egregious example of why we fear cache poisoning. How many of you do online banking? I do, right? My bank has not deployed DNSSEC. Okay. I suspect yours has not either. This is the stuff that we kind of worry about now. The internet is a much different place than when it was designed, right? All right, so the Band-Aid that we put on this one is, well, I thought I had another build. The Band-Aid we put on this one is if something in the additional section is not related to the domain that I just queried about, a resolver will ignore what's in the additional section. All right, so I ask about isc.org. You gave me an answer, and that's great, but if you send me something about another domain, in this case, bank.com, then I ignore bank.com. All right, this is how we solve that problem, right? This is the other issue, okay, and we've had some good talks on TCP, particularly TCP Fast Open yesterday, but so I won't go into the whole 3-way handshake stuff, but by default, DNS makes use of UDP, and this is great, right? UDP is really fast, really fast. It's great. We can ask. This is why DNS has scaled as it has, right? We don't have to tie up resources on or sockets, TCP sockets on authoritative servers or resolvers, right? We're just firing queries off, and we're expecting answers to come back. Okay. The problem is, though, I can spoof UDP packets, right? I can pretend that I'm you, and I can do all sorts of things when I do that, right? So here's how cache poisoning works. The very basics of it are, and this is where I'll scare you a little bit. If I know what questions your clients are asking, or if I know what questions your recursive servers are asking, then I can potentially poison your cache. And guess what? I have never looked at, I don't think I have any direct, nope. There's lots of folks that we work with, but I have never looked at anyone in here's query logs. I've never seen your query logs on your DNS resolver, but I still know what questions you're asking. I know you're asking about Facebook.com. I know you're asking about Twitter.com. I know you're asking about inadder.arpa. I know you're asking about Google.com, right? So if I know that you're asking these questions, then I can start to fabricate responses. They appear, like if you ask me about, if I know someone has induced you, hopefully a client has said, go look up google.com for me. And once that happens, I can be sitting there pretending to be google.com all day long, right? I can start flooding responses to you saying, yes, this is coming from the correct IP address that serves google.com. Again, there's some complexity that I'm leaving out, but I can say that. It appears to come from the right source. If I guess the query ID, if I guess some other things, then I can successfully poison your cache. Right? And in traditional cache poison attacks, there's also a thing that I haven't talked about, but it's TTL, and this is time to live, right? This is how long a resolver should cache a response, right? So if I'm trying to do cache poisoning, I'm very likely going to set the TTL to something like, I don't know, forever, because I don't want it to expire out of your cache, right? So it's going to have a very large TTL, okay? So all this is very scary. The most scary one, again, was the Kaminsky attack. And so this other part about what questions are you asking, all right, there's this other part of the internet that's a little scary too, in that, and I'll use Google ads as an example, right? If I buy a Google ad, I can embed things in that ad that induce you to ask questions of the DNS, right? Is anybody, just even for yourself, I know most of us in here are operators and we look at query logs a lot. Has anyone ever looked at their own query logs, like locally on their machine? Yeah, a few of us, okay. Were you surprised at the number of queries that are going out?
There are definitely sources or things that I wouldn't have known were going on yet.
Exactly. So if you do this, so if I'm just visiting, say, yahoo.com to check my spam mail where I send everyone, if I'm just doing that, then, and I'm looking at my DNS queries, suddenly, not only have I asked about yahoo.com, but I'm asking about all sorts of things that I have no idea what they are. Usually these are ad-based things, right? The ads that pop up, fire off some DNS queries, right? So given that, if I'm a malicious party, then I can induce you to ask some questions. And this was the magic of what Dan Kaminsky discovered, is that either by sending spam or embedding things in an ad, I can induce questions to be asked, right? And if I start asking random string questions, then I don't have to defeat any caching that you have going on. So this was always the trick with cache poisoning historically. I had to get an answer back before the real party, and I had to do that, and if the real party beat my malicious response, then I had to wait 2 weeks because that's what the TTL was to try again, all right? But if I'm asking you random things, I know they're not in your cache, all right? So literally, the other thing about cache poisoning is in the old days, it was always one record, right? For the internic example, www.internic.net was poisoned to point to www.alternic.net, right? So it's one record. With the Kaminsky example, I might even give you the right answer to what you just looked up, but I'm going to tell you that the name servers for the domain that you just asked about are mine, all right? If I do that, then suddenly any further DNS queries that resolver asks are going to ask my name server. Okay, this is bad, bad, bad. Very scary thing, right? Again, this, you know, and it wasn't that hard. The code to do this wasn't that hard. So if this had gotten out to the, you know, the script kiddies, then the DNS as we, the internet as we know it, people may have a different opinion of it, okay? All right, so a little bit about crypto before we actually go into DNSSEC, because how we accomplish implementing DNSSEC is by using asymmetric cryptography. Does anybody use PGP to secure their email? All right, a couple of you. If you do that already, then you already have the basics down for how we do DNSSEC, all right? It's public, there's keys created, there's a public portion and a private portion. If I sign my DNS, so on the authoritative side, if I sign my DNS data with my private portion of my key, then anyone that has the public portion of my key can decrypt that. We'll talk about the specifics later, but can decrypt that and prove that it came from me, that I'm the one that signed it, and that it hasn't changed in transit, okay? All right. So in general, crypto, as you think of it, has four purposes. The other thing I should mention is, since the Snowden revelations, I guess 3 years ago now, there has been effort to encrypt all of DNS, right? That's not what we're talking about here today. Again, DNSSEC is all about ensuring that the data came from the right place and it hasn't changed. That's it, okay? Total encryption is a whole nother beast, okay? So for DNS, this is all we care about, and I've said it a couple of times. Has it not changed in transit, and did it come from who it should have come from? That's all we're worried about, okay? So to do this, we do asymmetric cryptography, and we also do digital signatures. So again, we're not encrypting all of the DNS. We're just, we're going to hash our DNS data, sign it, and then send that out, okay? A little bit about this right quick. Excuse me. Symmetric crypto requires, if I want to have a cryptographic session with one of you, you and I have to have a shared key, all right? So if you think about all the domains out there and all the name servers and all the resolvers that are querying for those domains, you'll see very quickly that symmetric cryptography is impossible when we're talking about the DNS, okay? There's just no way that all of us could exchange keys, right? Can't happen, right? That's why we do asymmetric crypto. So again, with asymmetric crypto, I have key pairs. And again, there's a private and a public portion. When we do DNSSEC signing, I create a key. On the authoritative side, I create a key. I use that private portion of that key to sign my authoritative data. So when I do that, again, back to my very first example, www.isc.org with an A of some address, right? We're all good with that. When I do this with DNSSEC, then the only thing that changes for that particular record is that it has a resource record signature attached to it, okay? And then this other part, that anybody that knows my public key can use that to validate the response that they get from my authoritative server. Anybody have any idea how I can get all of you my public key information? Key server is one of them, and that's the way we do it with email, right? I encrypt my DNS, my email, and my key sits on, I don't know, an MIT key server somewhere, and that's great. Anybody think of another way?
Your email
Key exchange at NANOG, yeah. That's a good one. Well, here's what's so beautiful about this design is that if I want to get you a public key, I can just put it in the DNS. Boom. Then you can ask me, if I give you back a signature on that A record, then you can say, oh, you do DNSSEC. What's your DNS key, right? That's how it works. So that's really cool, actually. Let's see. Yeah. Anybody do crypto for fun in here, like in your spare time? All right. We usually have one. You laugh, but we usually have one guy. Anyway, no takers today. Anyway, if you're one of those people, you have a problem with this guaranteed thing. We kind of put it in here just for laughs, right? It's mostly guaranteed, right? There's people that, spend a lot of time trying to crack keys, so to speak. But in general terms, I can prove that the data has been unaltered, right? It was signed with the private portion of a key. I have the public portion because I got it from the DNS, and I can prove that it hasn't changed, right? And the same thing, since, again, it was signed with my private portion, and I have the public portion as a resolver, then I know it came from the right place, okay? All right. At this point, again, we're not encrypting the entire DNS transaction. That's not what we're doing. Other people are working on that. We'll see how it turns out. So what we can do, though, then, is we can, since if we encrypted it all, it'd be pretty expensive, right, in terms of like data sizes. And was anyone in the earlier DNS session today? Right. So they talked a lot about key changes and key sizes and how that affects our DNS traffic, right? What we really want from the DNS is these really small transactions. That's why, it's UDP, it's fast, it's great, and it's not very network impacting. But when you start doing things like having larger key sizes and stuff like that they talked about this morning, then you're impacting your bandwidth some. Compared to streaming, certainly not, but still, we want our DNS to be nice and small and tidy, all right? So at this point, we're not encrypting everything. We're hashing the data, and we're creating a signature based on that hash, okay? And again, this is what I've said a couple of times. All right, so how this looks in a pretty picture is I have my DNS data. I do some hashing, which creates a hash. I then encrypt that hash with the private portion of my key. So what I send to you, you can think of this as on the very top half of this slide, all of this happens on the authoritative side, right? When I DNSSEC sign a zone, it happens on the authoritative side. On the lower portion of this slide, if I turn on DNSSEC validation on a resolver, that's what's going on here, right? So a resolver asked a question, I gave it back the answer and an associated signature. It can get my public portion of my key, of course, because that's in the DNS as well. So it can then do the same hashing. It can decrypt the hash, and if those hashes match, then we're good. All right? There's a little more to it. We have to, and I'll talk about the chain of trust here in a bit some more, but this is the very basics of how it works, all right? Now, the thing is, on the authoritative side, I can DNSSEC sign my data. If a resolver is not doing DNSSEC validation and they get back a signature, then how they react is they just say, well, whatever. I don't care about that. I'm not trying to do DNSSEC validation. So again, the protocol is really old, 30-some years old, and actually DNSSEC is, I don't know, probably approaching 20 years old. So, we still haven't done it, right? The battle continues. But anyway, the whole thing with DNSSEC is that, and I love being able to say this on June 14th, but there could be no flag day, right? Couldn't have a flag day where we all said, today everyone's going to sign their zones, and we're also all going to validate. Just wasn't going to happen. All right. So administratively, these are the things that you need to think about when you are going to consider deploying DNSSEC. Right? And again, I want to stress that everything that I've talked about so far, and in this section as well, this is all name server software agnostic. You can do this with any name server software. They all do it, okay? NL Labs has NSD, which is an authoritative server. It doesn't have signing function, but you can use OpenDNSSEC to do your signing with NSD. So all this is all name server agnostic. All right. These are the decisions you need to make. And again, if you attended the sessions right before this, you already know some things about algorithms and key sizes in particular, okay? So you're going to have to decide what algorithm you're going to use, how large your key is going to be. NSEC and NSEC 3. All right, here's a fun one about DNSSEC. All right. In all the examples I've used so far, I've talked about for something in between these two entries, right? Because that doesn't exist, I'm going to create an NSEC record that lists A and C. I'm going to assign that record. All right? That's pretty straightforward. All right. NSEC was one of the reasons that DNSSEC deployment was delayed for so long, right? A lot of operators did not like the very fact that you could query a zone and enumerate it. All right. So if you're a person that doesn't allow zone transfers of your data, then you're not going to like NSEC, right? Because I can sit here and query you, and there's actually scripts out there, of course, that will do it for me, right? I don't even have to write the code. I can query your name servers, and I can figure out every single entry in your zone, right? This is one of those religious things, right? There's some people that say the DNS is public. You know, it's public data. You know, this shouldn't matter, right? And then there's others that say, well, no, I don't want everyone to know what's in my zone. If they query for something that exists, that's fine, but they knew to query for, right? So depending on which camp you're in or the policies of the organization that you work for is which one you will choose to prove non-existence, right? NSEC is the most straightforward and easy, but NSEC 3, it turns out, is not that difficult to grasp either. The difference is, if I take that same example of A and C, the only difference with NSEC 3 is that I'm now going to hash A and C. All right, so I hash A, I hash C, you asked for B, so I'm going to create an NSEC 3 record with the hash of A and the hash of C that says that does not exist, and I'm going to assign that. Okay? Has anyone in here DNSSEC signed a zone? Excellent. What was your reaction when you first signed that zone and you looked at that zone? Oh, okay, okay. Y'all been doing it forever. So Kudos to Comcast. They were one of the first large ISPs to turn on DNSSEC validation, right? But the point for you as DNS operators, if you're an authoritative operator, is that when you DNSSEC sign a zone, it creates lots of records that you're not familiar with, okay? There's going to be these signature records, and there's going to be either INSEC or INSEC 3 records as well, okay? All right, here we get to a very tricky conversation, all right? If I want to sign a zone, if I want to sign example.org, right, I create a key and I sign that zone. Everything's fine, right? Not a problem. I only have one key. That's entirely valid, okay? The problem is if I don't want to get any of my registrar people in trouble. Anyway, the joke about DNSSEC is that the trouble comes in when you have to talk to your parent. All right, so that's the joke that you can remember. Oh, I have to talk to my parent, you know. So if I am I'll pick on VeriSign instead. If I'm example.com and I sign my zone, then whenever I want to do a key rollover, and this was one of the topics in the earlier session, but every time I want to do a key rollover, I'm going to have to talk to my parent. I'm going to have to talk to who runs .com, right? Because the way this works is, again, when we talk about the vanilla DNS and the way that was designed, we use, for chain of authority and for delegation, we use the NS record, okay? That NS record has to exist both in the parent and the child, parent domain and the child domain, okay? So whenever you created your domain, the parent then puts those name servers into the, in this example, into the .com zone, right? Example.com has ns1.example.com, right? So with DNSSEC, you have to have what I referred to earlier as a DS record, delegation signer. So the delegation has been made with the NS. I now need a DS to do the signing, right? The parent has to do that. All right, so this is why in normal operational practice, what most people decide to do is have 2 keys per zone. I have a zone signing key, which I sign all of the data in the zone with, except for the DNS keys. And then I have the aptly named key signing key, so that I sign the DNS keys with that, right? So what happens is, how you create a DS record is you provide a hash to the parent of your DNS key. So if you only use one key, that's fine, it works, but every time you do a rollover of that key, you have to talk to the parent. Okay, so this, depending on who your parent is, this can be a problem, right? I know many organizations that they have their ZSKs rolled really frequently, once a quarter per the recommendations, and they've actually never rolled their KSK because it's such a pain to get the parent to accept a new DS. All right. This is much better these days. I will say there's some really good news for you all. If you have not deployed DNSSEC yet, it is so much easier than it used to be. All right. I was thinking back, the last time I was in Chicago, I was giving a 3-day class on DNSSEC. Right? Now I can pretty much tell you all you need to know in 90 minutes. That's nice, right? The other thing I was going to tell you is some bad news is I have a really bad headache today, but the good news is that it's not due to DNSSEC. So that's good. I've had several DNSSEC headaches. All right. All right. So which algorithm are we going to use? This really depends on if you are required to support some legacy systems, then you're Most parents, how you do this is you run a tool based on whatever name server software you're running. Again, they all have them. You run a tool on your DNS key that says create me a DS, and then you give that DS to the parent. So for the example.com example, I've signed my zone, I have a DNS key, I give the hash of the KSK to my parent, .com puts in the DS, and that lets everyone know that this chain of trust is established. The good news for you all, some more good news, is that the root has been signed, okay? So now you can trust, you have a chain of trust all the way back up to the root zone. Back when a lot of us were first deploying DNSSEC, it's a layer 9 issue, right, about who was going to sign the root. It's a very political issue, right? So it took a lot of time for that to get worked out. It was actually signed in July of 2010. So now that that's done, you really only have to have what's called one trust anchor in your configuration, okay? All right, so your technical decisions, all right. Here's the very basics of those of you that have large scale, and this is these are the technical decisions on the authoritative side of DNS. If you have a large scale authoritative service, then these are the decisions that you have to make. All right. So everyone that I ever talked to has some really crazy special sauce on how they do their provisioning, right? A lot of times it was written by someone 10 years ago, and people run scripts and they don't really know what's happening. They just know when they want to add a record or a zone, they type this command and it magically happens. All right, so this is where we find most people. I see some head shaking. This is where we find most people, right? You have this magic that's provisioning. So one of the delays in DNSSEC deployment was originally you had to change this magic, all right? That's a problem, right? So the good news, again, for you guys, if you haven't deployed, then you have some other options, right? You don't have to change all the magic. So here are the options to DNSSEC sign a zone. And again, pointing out, I say this a lot, but this is name server software agnostic, right? All the name server softwares out there can do these things. So whatever yours is, you can induce it to do it, all right? You can do manual zone signing. In 2016, just don't do that. Just don't. Trust me, do not manually sign your zone, all right? In the old days, you know, just to give you some of the war stories, when you sign a zone in the old days, if it was a sort of a static zone, it didn't change very often, then you've probably heard some war stories about signatures expiring. Or something or you heard about a DNSSEC problem and it was related to something expiring, right? So I want to make clear that keys themselves do not expire unless the only time you expire a key is by policy. It's not by protocol and it's not by name server software unless you tell it to do so, okay? Keys don't expire, signatures do expire. So generally speaking, default setting is when I sign a zone, each record has a signature that has a 30-day plus 1 hour lifespan. All right. The plus 1 hour is to give some people a break if they're not using NTP, right? Here's another tip. Use NTP, all right? DNSSEC is very time dependent. So make sure your name servers know accurate time, all right? But if you had, in the old days, if you had a zone that didn't change very often, you'd sign that zone, and then about 30 days later, people would say, I can't, there's a problem with that zone. So then you'd issue the command to re-sign it, and about 30 days later, the phones would ring again, and you re-sign it, right? This is because the signatures were expiring. Now, if you had a zone that you had that wasn't static, it was pretty dynamic, you were adding some things to it. When you manually re-signed, then the older signatures got recreated, right? So this is a problem that if you do this right, you just don't have to worry about this. And this is the whole point I'll try to make to you for DNSSEC. In 2016, there are so many ways for you to not have problems with this, right? So good, This is good. So your other options are you can do automatic signing of dynamic zones. How many of you use dynamic DNS? Yeah, okay. So this is even better news for those of you that didn't raise your hand, because if you're not doing dynamic zones, then this becomes like a really, really simple thing for you to do. Says the DNS guy, right? You know, pretty simple. You can do what's called inline signing, and you can do this either on the box itself, or you can do bump in the wire. And I'll show you sort of graphical examples of each of these. But again, the main point is with these last two, this whole provisioning DNS magic stuff that you have can stay exactly the same, right? We just leave that be. Let that, don't poke that dog, right? All right. Again, I'm not going to harp on this too much because you just shouldn't do this. If you manually sign, you have to do things like insert the keys themselves, and just don't do this, okay? If you want to do this, please come talk to me afterwards. I'll give you my card. You'll need it. So people that didn't like dynamic zones back in the old days, a lot of them actually converted to dynamic zones just so they could deploy DNSSEC because, and this one is bind specific, but in 9.7 we made it much easier. So you could just if a DNS update came in, the zone would be updated and automatically signed. This made people's lives much easier, okay? So inline signing is what you really, really want to use. And we have some more slides that I think will make this a little more clear, but one of the problems with the original DNSSEC deployments is we're used to a zone file that has a certain amount of records in it and records that we understand. When we DNSSEC signed those, then all of a sudden we had the base 64 resource record signature records in there, and the INSEC records. It became very confusing to look at one zone file. Okay. If you do inline signing, then you get to keep your same zone file. All that's nice and pretty and plain old 30-year-old DNS in there. That's great. And you don't have to see all that other stuff in there, right? The bump in the wire one is the one that typically we recommend to most parties, right? And the slides will. I thought I had a slide in here. Yeah. I'm just going to skip forward to this one right quick, but this would be your sort of existing implementation. You have a master server and you have some 3 secondary servers over here. This is how, typically you have one master that's where your provisioning happens and all that's good. It may or may not be a hidden master, but regardless, if you do if you do inline signing, then you very simply just add another device midstream, and the only thing that changes is where the master transfers its zones to, and then the secondaries get that data from the inline signer. And you do your signing right on that box. So, again, that whole magic stuff can stay the same. All right. Okay. So this is the part where I will give some bind-specific examples, but again, your name server software will have the same or similar tools to do the same things that I'm talking about, okay? This is a very handy slide, right? And I will point out that the slide set is available for download, but if you're going to DNSSEC sign, these are the steps right here. This is it. And again, at this slide point, there's no name server specific stuff, right? You're going to generate keys for your zone. Again, you can do one key, but that will make you talk to your parent more often. Probably don't want to do that. So you're going to do 2 keys per zone. You get those keys into the zone. These days, for bind specific, and I think the other software as well, you just essentially tell the name server software where the keys are. So you don't have to actually put the stuff into the zone data itself. You sign with those keys. That's usually these days just one command instead of several commands, just one command. You then publish that signed data. How you publish that is just like you publish your zone now, right? You're just pointing to the DNS authoritatively is just, it's just a database. There's a file that exists somewhere that has your data. In DNSSEC, that same file is there. It just now has signatures and other DNS data. Okay. This is a very important point as well. You can do the first, how many is that? 1, 2, 3, 4. You can do the first 4 steps here all day long, and you're not going to cause yourself any problems, no headaches, no phone calls, right? So my recommendation is do these 4 steps a lot, right? Play around with your zones. You got some zones you don't really care about that much. DNSSEC sign those first, right? Do this stuff. Because the go live moment for DNSSEC for you as an authoritative DNS server operator is when that DS goes in the parent, that's the go live moment, okay? If that DS goes in the parent and you still have a problem with your DNSSEC implementation, then people who ask about your zone who are doing validation are going to get back serve fail, right? So I just tell people, like, one of the things with DNSSEC is just really like take your time, right? Take your time and play around with this stuff, know what you're doing, and then you're not going to have any problems, right? Once the DS is in the parent, then, assuming everything's working okay, you can then validate DNS queries. Okay, this is what we all want. All right, again, this one is bind specific, but here's a little, if you wanted to script this, you could. Here's a little bash script. And I think, do I have the highlights? No. I had to cut some of the slides because of the timing. So essentially, we here are for a zone, we're going to create a ZSK, and then we're going to create a KSK. Right? There's a tool in bind called DNSSEC Keygen. The other name server softwares have their own tools. Many of them are very similarly named, which is pretty cool. So anyway, once we have the keys created, if in this particular case, we're going to sign with INSEC 3. So we issue, so for those of you that run bind servers, how many of you run RNDC pretty often? All right, cool. So you're way ahead of the game. If you want to, so you create these keys, you just run RNDC signing on this zone, and then you tell bind to sign it with RNDC sign, and you're done. Good. Again, these slides are available, so please go back and reference them. The fun little part that I told you about inline signing, this is how you do inline signing. So if you're going to do it on sort of bumping the wire inline signing, this is what your named.conf config would look like. DNSLab.org, this is where my master data exists in this file, master/DNSLab.org. I'm going to do inline signing, and I'm going to do auto DNSSEC maintain. Okay, if bind knows where to find the keys, then I'm done. I put this in named.conf. Bind knows my keys exist in some directory. I then do RNDC sign of this domain, and I'm done. It's good, right? And again, I can do this part and not fear the phone ringing, right? I can RNDC sign, and I can start doing digs against my name server to get back signatures, and everything's good. DS in the parent is when I have to worry about the phone calls. All right. So again, this is what I pointed out earlier. This is the main recommendation that we give to people these days. Don't touch your provisioning. Just put something in between. That's a signer. I will point out here as well that as with my earlier slides, this is a very simplistic representation, okay? Usually you have some way, even though there's usually only one true master in DNS, you usually have some way where the master is backed up. There's some high availability thing going on there. You usually have probably more than 3 secondary servers, and if you implement signing infrastructure, you're probably required to have it be redundant and high availability. All the same things apply in general sysadmin for that, right? But in the simplistic example, we have this inline signer here. We have an unsigned zone file. We do RNDC reload. Now we have, still on the master server, our zone remains as it is. So again, you're not changing anything on that side. Then we're just going to do standard zone transfer things that every name server can do. And we do RNDC sign on that server, and that's where the signed data comes from. We then can send out that data to any other name servers that we want to. Okay. And we do that via standard zone transfer as well. Okay. At this point as well, so in this example, this inline signer is running bind, but I could have, and we know of lots of parties that have sort of a heterogeneous environment, right? So I'm running bind on one, NSD on another, not CZ-NIX, not DNS on some other. All this is just speaking protocol. I could even transfer it to a Windows server if I wanted to, right? So all that's good. Right. Every 15 minutes, just note that initially when you do the signing, it's only in memory, but every 15 minutes there will be a flush out to disk. And I guess I missed one build there. You can also do RNDC sync if you want to flush what's in memory out to disk as well. All right, what that config looks like on the secondary server is you have the zone type slave, you have the list of the master, you can send notifies to any other list of servers if you want to. You're doing inline signing, and you're doing auto DNSSEC maintain. All right, you do that, and then RNDC retransfer and RNDC sign, which you'll see in a few minutes, and your zone file is signed. Okay. All right, I said a few minutes, but it's actually next slide. All right, so here is another good reference slide. If you do run bind, these are the steps that you would take. Again, we're creating two keys, a KSK and a ZSK. We're going to sign in this example with INSEC3. We retransfer the zone, and then we sign the zone explicitly. Okay? All right, let's see here. All right. So everything I've talked about so far has been on the authoritative side. All right? The authoritative side is the more complex place for enabling DNSSEC. All right? What I'm going to talk about now is on the validating side. So if you run resolvers on behalf of your customers or your clients, this is how you turn on DNSSEC validation. This was the kudos that I was given to Comcast earlier, that they were the first very large ISP to do this. So note that, and I said this earlier, but if I sign my zone, isc.org, anyone that asks me a question about isc.org is going to get back an authoritative answer. So in the DNS headers, there's going to be the AA bit set. That will always be the case, even with DNSSEC, right? I'll give back the A record, and I'll give back the signatures. It's up to a validator to actually validate it, okay? And the validation happens on the recursive server side, okay? Let's see. This is what I was talking about with the trust anchors. Now that the root is signed again, we can track all the way back up to the root. So this is our chain of trust. All that is good. If a resolver is able to track all the way back up and validate the data all the way back up, then it will return to the client the answer to the question, and also in the header there will be an AD bit. This is how a client will know that I'm getting authenticated data. I can trust this DNS data. Okay. All right, this part is very important. If you were in the session earlier, this is something that I want to make sure that you know. Okay, the root KSK, the root was signed in July of 2010. The KSK of the root zone has never been rolled. Okay, yeah, I see some crazy looks like, oh my goodness. All's good, right? The key is fine, it's secure, everything's fine, you know. In the policies for when we were going to roll the root zone, it said we will roll the root KSK at some point after 5 years. So that leaves a pretty open-ended, like, when are we going to do this, right? Well, we did reach the 5-year mark, of course. So the root key is going to be rolled, and ICANN gave a presentation in the earlier session about what those dates are. October of this year is one date, that October 11th, that you need to worry about, and January of 2017 is another date that you need to worry about. This is if you are running resolvers that do DNSSEC validation, all right? So when they roll the KSK, what that means is they create a new key, right? They sign their zone with it, okay? You have to, in a resolver, you have to have the root trust anchor so that you can do this validation all the way back up to the root, okay? That trust anchor is going to change, okay? So you need to be aware of this. Those of you that are running, whatever name server software you're running, when you go back, or if you're logged in now, check and see, you know, what your trust anchor is set to if you're doing DNSSEC validation or not, okay? So we initially start with this trusted key, and this is the one that's current, but what happens if they change the root KSK, and they are going to change the root KSK, all right? The preferred method is that you use what's called managed keys to set your trust anchor, right? If you set managed keys, then when the root rolls its key, your server is going to be fine, there's going to be no issues, right? If you're using trusted keys and you don't add the new key to your list of trusted keys, you're going to have some problems. As in, DNSSEC validation for your clients is no longer going to work. As in, every single query for a domain that is DNSSEC signed is going to be returned serve fail to your customers. This is probably not what you want, right? A little bit about RFC 5011 or 5011. You can read the text here, but essentially if I publish a new key and it remains for 30 days, then a resolver can know that, oh, I can trust that key, and I add it to my trusted keys list, okay? But again, with bind, you want to make sure you use managed keys if you want to make use of 5011, okay? Yeah, so here is our recommendation. The root KSK is going to be rolled, so we do recommend that you use managed keys. So, but very simply, remember I said turning on DNS or enabling DNSSEC for a resolver is much simpler than it is on the authoritative side. For bind, this is what your configuration looks like. DNSSEC enable, yes. DNSSEC validation, yes. Here's my managed keys. If you have this in your named.conf, then you are doing DNSSEC validation, okay? If you have the first two, DNSSEC enable, yes, and DNSSEC validation, yes, and you don't have a trusted key or a managed key, you are not doing DNSSEC validation. So go back and look at your config and see where you're doing. All right, I think I have 15 minutes. So we're going to have to go fast now. Remember, if you've been a DNS admin for a while, you're just providing data. As an authoritative server, you're just providing data. As a validating server or as a recursive server, you're just looking up data and providing that back to clients, all right? No big deal, right? With DNSSEC, all that remains the same, okay? There's the stuff that we talked about to enable validation and authoritative DNSSEC signing, but other than that, it's still just data, right? So these are the new record types for DNS that were introduced with DNSSEC. And instead of reading them out, I'll just go through them. So your DNS key records are going to have what algorithm you chose, the key type you're using, the key tag, which is it's just an identifier of the key itself, and then the actual keying material. So this is a DNS record, and this is a DNS key record. This is what this will look like in your zone, right? Here's your label, TTL and class. Class, for our purposes, is always going to be internet or IN. This is a DNS key, flags 256. Note, this is very important when you start debugging DNSSEC, right, if there's DNSSEC problems. If you see a flag of 256, this is a ZSK. If you see 257, this is a key signing key, And why is this important for debugging DNSSEC? Because remember, the DS that's in the parent is built off of the KSK, right? So one of the ways you start debugging DNSSEC is, well, does the DS in the parent match the KSK in the child zone? Okay. 257 means that the SEP bit is set, secure entry point bit is set. Okay. Protocol is always going to be 3 for DNSSEC. Algorithm is 8 in this example. This is RSA SHA 256. Okay. And then the key material, technical term, gobbledygook. That's what it looks like. And then if you dig plus multi, it will actually show you what type of key it is, the algorithm that was used, so a human can read it, and the key ID itself. Okay? All right. Resource record signatures are going to, and I'm going to speed through this a little bit so that we have some time for questions. This is what a resource record signature looks like. In this case, it's the example I've been using, www.dnslab.org. This is for this A record, has this resource record signature. So this signature is covering this A record. Again, algorithm. This is the depth of labels covered. So this is the way that you can still do wildcarding with DNS to have it work with DNSSEC. Okay. Original TTL of the original A record, and then of course, remember I said dates and times are important. These are the expiration and exception dates. Okay. Remember, keys don't expire, but signatures do. And then key ID, the label of the zone essentially that this key was, or this signature exists in, and then the signature itself. Okay. So in our original zone file, we had this underlined part, www.dnslab.org. Now that we've signed this zone, we have the signature. Remember at the very beginning, the thing you want to remember about DNSSEC is that DNS data is augmented with a signature. Here it is in practice. All right. So DS record I've talked about quite a bit. This is how we establish our chain of trust. But let's look at what the record actually looks like. This is a DS record for dnslab.org. DS record key tag and the key algorithm again. Hash algorithm that was used when the key was created, and then the actual hash itself. Okay. This record exists in your parent, and your parent signs it. Okay. Of course, you're going to have a DS record, and then you're going to also have a signature of that record. Okay. So every DNS record, when you do DNSSEC, is going to have a signature of that record. All right. So what you'll see is on the parent side, we have a DS 9247, and on the child side, we have a 257 DNS key that has the same key ID. Again, in debugging DNSSEC, these two have to match. If they do not match, then you're going to have serve fail, or the clients are going to see serve fail. All right. Now, DNSSEC in the real world, just very quickly, and well, it's not my laptop. Anyway, DNSViz.net is your friend, right? If you have already deployed DNSSEC validation, then remember, you're the operator that's going to get the call if there's a DNSSEC problem, no matter if it's your problem or some authoritative server's problem, right? DNSViz is the way to debug it. It gives you a nice graphical printout, and it alerts you to where the problem is. So if you're the validator and an authoritative operator has caused a problem for themselves, then you can report that problem to them and say, fix this part. Look at this DNSViz report. All right? Highly recommend this tool. It's really awesome. What we've talked about so far is DNSSEC on the authoritative side and on the validation side. All right? Remember I asked earlier if I had any DNS geeks and was anyone running a validator on their laptop. I actually run two. I run Bind, of course, and I run NetLabs Unbound, because there's this thing called DNSSEC Trigger. So I can guarantee you, how many of you Well, most of you are probably from out of town. How many of you are staying at hotels? Did you use the hotel wireless? Yes. All right. Did it require you to log in? Yes. Okay. How they did that was they lied to you. They had the DNS lie to you. You asked for something, and they said, oh, the answer to that question is my portal where you log in, right? That's a DNS lie, right? Well, that makes it problematic on the client side to do DNSSEC validation, right? But NL Labs has this really cool tool called DNSSEC Trigger that I highly recommend. And it gives you a way, it detects when you're in an insecure environment, and it asks you essentially, is someone trying to lie to you so that you can log in on a guest wireless? You say yes, you do the little transaction, and then you can go back to validating DNS, okay? Let's see. You can also do validation in the browser. CZNIC has a validator that's for Chrome. I believe the latest versions of Chrome actually have it pre-installed. Okay. All right. One last thing about, we've talked about keys. All right. So key rollover. Again, you never actually technically have to roll your keys. It's just recommended that you do so that you know how to do it, so you don't cause problems if you have to. And if you are a high-value target, you do need to roll your keys. That's why there was a whole presentation on rolling root keys earlier today. All right, this is this is a slide about the output of DNS Viz, and I'm not going to go through this, but if there were to be a problem in the thing that I looked up, it would show up in one of these graphics. It would be red, and it would say, here's the problem. So again, this is your friend as a validating operator. All right, so yeah, now that I got trust anchors, I can trust everything. All right, key rollover. This is the scary part of DNSSEC, or another scary part of DNSSEC, right? Here's what I'll tell you if you, because I want to give you some time for questions, but when you do key rollover, here's the thing to remember. Allow yourself plenty of time. You do not have to time these things perfectly, right? So the part of the problem here is if I sign my zone and people are asking questions about my domain, then this whole loose coherence of the DNS is a bit of something that I need to take into account, right? I'm asking a question. That question and response will get cached. But if someone's doing validation, they then have to look up my keys. And if I change my key and they still have the old one cached, I'm going to be in some trouble, right? Because it's not going to validate. So KSK only signs the DNS key RR set. ZSK signs everything else that you're authoritative for. When you sign your zones, it does create larger zones, right? So we don't usually want to create two keys and sign with both of them, right? So you do KSKs and ZSK roles differently. For the KSK, we're only signing the DNS keys, so we don't mind double signing those. That's fine. It's not going to create much more space. But if we did that for the ZSK, then we're creating a much larger zone file. So these are two mechanisms generally used for rolling keys. For KSKs, you do double signing. For ZSK or ZSK, you do pre-publish. These are really good reference slides, these next two. All right? This is the timing of how you do a ZSK rollover, right? Once you get all your stuff signed and everything and you want to do rollover, make sure you practice this and develop a policy for how you do the rollovers, okay? Again, make sure you allow yourself enough time, right? So here we're generating a new key, right? We just make a new key. We publish both of those keys. That's fine. We're only going to use the old one for signing, but the new one's out there, right? We wait at least the time to propagate, meaning time from my master to all of my secondaries, and the TTL of the DNS key itself. We wait that amount of time, okay? What I want to emphasize in all of these is wait at least that time, right? If that time works out to be 1 hour, wait a day. You know, it's not going to hurt you to have these extra things hanging around. It is going to hurt you if you make changes at, say, 55 minutes, okay? Use your new key for signing. Keep your old one published in case anyone's still referencing it. wait this minimum amount of time again, and then again, minimum. If that works out to be 24 hours, wait 48, et cetera, et cetera. You get where I'm going. At that point, you can remove your old key and you can re-sign. KSK is very similar, except we're doing a double signature this time because we're only signing the key signing keys. So I'll leave this as reference. You can go back and use this when you start doing DNSSEC and key rollovers. Current NIST recommendations are KSK once a year, ZSK every 3 months. All right, with that concludes the slides and the talk. So we have a very few minutes for questions. If anybody has any questions, please do ask. And I will be here after the session, so I don't have anything to do other than lunch, and I'm not hungry. Yes?
Ryan Rodden from Conversant. I've noticed the first 4 steps you say can be done anytime, but it goes live with the DS key being published,
Yes.
or the DS record being published upstream. Are there tools out there that will let you say, or that you know of, that you can say, here's a DS record that I want to publish, validate everything against my authoritative servers?
There are tools in the making to do that. So, one thing I left out overall is that automation has come a long way, and actually in the current version of CZ's NOT DNS, they have a key manager, and with Bind 9.11, the alpha is out now, we have a key manager where essentially it says, for this zone, I want this type of key, and I want it to last for this amount of time. So it will do your ZSK rollovers automatically.
So in terms of testing pre-deployment, no tools that you know of, like DNS Viz will do this, so you can say, test with this DS record?
For that, what I would do is I would sign my zone with my new KSK, and then add that KSK's trust anchor to a test resolver, and then I can use the test resolver to make sure that the queries validate.
Okay.
Good question. Yes, sir.
Is this an all or nothing implementation for something new? Can you do like one authoritative name server, and then is there problems with doing it that way if I want to spin up a new one and do testing that way and leave my production ones?
It is all or nothing as far as when the DS goes in.
Yes.
Yes. When the DS goes in, it's all or nothing. Now, before that point, you could do signing on, say, one authoritative server and one secondary server and do testing, and all that's fine.
Okay.
But when the DS is there, it's, everybody needs to know about signatures at that point.
Okay.
Yep.
Hey, so you mentioned that when the AA bit was set on the query answer, that the AD bit is also set? Correct me if I'm wrong
No.
there.
So if you're a resolver and I'm authoritative and you ask me a question, I'm always going to return the AA bit to you, right? But if he asks you that same question and you're able to do validation, you will return the AD bit to him.
Okay, and is it his responsibility to do validation as well, or does he just stop and accept that this data?
If he's asked you to do the validation on his behalf by setting the DNSSEC OK bit, then he'll just say, oh, he did the validation and I'm authenticated and everything's great.
Cool.
Yeah.
Thank you.
Yeah, no worries. I have a question. The lights are sort of bright in my. Is that Will Parker in the back? Awesome. Will Parker's in the house. Hello, Will. All right. Well, that's it for me. Again, I'll be around, so catch me if you have any questions. Thanks.